any people who didn't catch the earlier presentations. Start out maybe with something that covered a bit in your presentations, but maybe we could throw out a few more examples. Here, could we talk about what are the initial use cases that you're targeting with quantum computing, and how far off do you think they might be achievable? And start with Dani and go down the line.
Sure. Yeah. I mean, I think the latter part of that question is a challenge. I mean, use cases. I think if it's kind of a question of not what but when. I mean, quantum chemistry seems like there are some particular use cases that we're seeing that really could, find an area of advantage, or at least a path to advantage for different types of materials or interactions, molecular interactions and different phenomenology processes that could be really interesting. Now, as far as how far those are off, it's really going to depend on what type of hardware we find or partner with to implement those on real hardware. Right now, we're doing a lot of that in simulation, not necessarily on real hardware. So, of course, we're always looking at different ways to understand the benchmarking of these platforms, but I will not try to guess when that type of thing would be field or deployable for our customers.
I think of this in a way as your question about when it's going to be useful is going to be so dependent on each of us, because in my mind, the dependency of when an algorithm is going to be useful or when a use case becomes competitive really depends on a lot of things that are out of the rest of the audience's control. For instance, if I have a process that we're using internally, I have so much compute resource that's available for that process to use that I'm willing, that my company is willing to expend in getting that compute problem, that design problem solved. Similarly, we'll have the same kind of restriction on what we're able to do with any kind of quantum solution. So that may be a situation where we may be highly advantaged in that we can go get quantum resources where we're not able to get that many classical resources to solve that particular design problem. Jasper and I were talking in our companies. In my company, the vast majority of our high-performance compute resources are tied up doing computational fluid dynamics and aeroelasticity problems. There is a lot less time available to solve computation or to solve combinatorial optimization problems computationally. So does that mean that those are the best thing for us to focus on? Well, maybe, because I really have to think about them as having a constrained resource available on the classical side. So where that scaling point becomes competitive for me is going to be different than where it is for Jasper or where it is for Dani, because they have different resources available to them. And again, they may be using different quantum resources as well. So it's not, I think, there is this general consensus out in the community that is focus on when are we going to achieve advantage. I think it's an illusion. Advantage is something that there are going to be 1,000 potential advantages that are going to be realized at thousands of different places. And it's not about when is the one that's the first going to be achieved. It's about when are you going to be able to find one that works for you and put it to use. That's what matters. So I know that's a way of kind of sidestepping your question, but I think for me, it's the more useful way to frame how I approach the problem of figuring out what we're going to look at and how we're going to go investigate them.
Yeah. So from the Airbus side, the approach is to find at the moment as much synergies as possible to exploit use cases. So we have a very central approach. We have these, I don't know if we have these use case clusters. They are fed by use cases coming from the business unit, so the needs. And so this is, and there are lots of similarities. So we are trying to avoid that, different teams investigate basically similar use cases. So this gives us, I think, a kind of coherence. The use case we are we are then choosing in the end. We have a certain metrics behind, right? So we are deciding the business impact, the expected performance from a quantum computer, the time scale and the level of investment. So we are then deciding which of the use cases are the most useful, and then those are the ones we're exploring. But this is also not fixed. Yeah? So of course, it's kind of agile. If we see some of the use cases don't make sense, then we drop them. So which of those are the most recent ones? I think I agree with Jay. It's not so much about to have now the quantum advantage in 5 years or in 6 years. I mean, this is for us as a large company not so much key, but it's really to make sure that we prepare ourselves for the advent of quantum computing. Because even if there is a better solution available, it doesn't mean automatically it's used, right? Because it's a different approach. So we have to prepare ourselves. And so I think there's a lot of things which also is in our role now to prepare our companies to be able then to adopt that. And from the fields, I think that's something I would like to stress. I mean, in the end, it's clear some use cases will come in different stages. So just the level of requirement from the hardware side is not the same. I would say for aerospace, CFD, equation solvers, this is probably a very challenging use case, or a challenging algorithm set. So this will probably take some time. So maybe we are not the first industry to really exploit this fully, but we will have many other opportunities also to use in other problem domains this early.
Doesn't mean we won't exploit it. We will definitely exploit it when it's available.
Yes, when it's there, yeah, for sure. But we need then also the computation of basically fault-tolerant devices with a certain number also of qubits.
Yeah, I think everyone has kind of spoken to this of, it's we're trying to build up to the point where we can do this, and it's still a little ways away. I think one thing that we're also trying to take advantage of is these like quantum-inspired classical algorithms, and so like I think from last week or the week before that, one of the MIT groups put out a really cool classical optimization routine, so inspired by things like the Hamiltonian variational ansatz that take advantage of symmetries in the problem space that previously we weren't really doing. And I think that we can kind of try to focus on some of these today and reap benefits over our current practices that we otherwise wouldn't have been aware of just because we wouldn't fully know. And so sometimes this can be just breaking the quantum algorithms themselves down into tensor network definitions, so using like MPS and PEPS representations to kind of understand the entanglement spectrum that's going on in one of these algorithms, and then seeing if there's like a minimal entanglement, if we can implement something of the sort classically. And so I think, I mean, you all have spoken to how far off we are from a quantum perspective, but I think also, like today we could maybe be taking advantage of some of these algorithms, whether it's in recommendation systems or optimization or even other things. So.
Yeah, in general, there's a lot of hype about quantum computing. Is there anything in particular that you think is overhyped, either in general or in terms of perhaps what is sometimes thought could be done with it in aerospace?
I mean, I think in general, I think I talked to it. Education is unbelievably important when we're talking to stakeholders and individuals like customers and things like that, even internally, on how we're realistically setting expectations. Even when we talk about use cases and the way we're all shaping these things throughout our different roadmaps, we have to be very careful on how and who we're partnering with and how the greater industry is driving that, because then our leaders see that, our customers see that, and they say, well, why aren't you partnering here? Why aren't you doing this? And that can drive things. So what is the biggest hype? Hard to say. I mean, I think quantum, like if we take pages out of other industries like nano and other things, we have a lot of lessons learned, and there are a lot of consortiums and groups that are trying to address that. So we can educate the customer, educate the public, the educators and things like that, to say, no, these are the things that matter. These are the things where we see, some sort of path to advantage. But I'd be curious to see what others say, and I'll say if I disagree or not.
I was trying to think about that, and the one thing, it's not a hype thing, but it's really, it's a byproduct of the hype that really is, I've found challenging within our corporate structure, is we have a group that's basically our own internal investment arm. So we have both a fund that we've done where we've seeded a fund outside that we have doing investment in companies, and we have an internal fund that does that as well. And what I find is that the people in those particular funds think every investment in quantum must be a home run. And I think that, to me, is not hype itself, but is a byproduct of the hype and the inability. I think the earlier panels this morning talked about, if you're doing your job as somebody who sits in one of those roles, you are discriminating. And hype and discrimination are something that don't really go together well. And so I'm seeing that in some areas of our company, in my company in particular, where we're seeing a lack of those two things laying on top of each other. We're being able to look at the hype and be able to be discriminating of what parts of that should we be able to focus on, what parts of that should we be able to ignore, or how should we be able to discriminate between what is hype and what is not. And so often I get people coming to me with, hey, this is the greatest thing ever, and we should go invest a lot of money in it. And I have to go sit down with the people and spend hours of time educating them on why that isn't necessarily the best thing for us to do from an investment perspective, maybe from a technology perspective, maybe from a strategy perspective, but they're not discriminating in any of those ways. So that's one of the things I see.
Yeah, maybe so to complement, so from my perspective, I would say that so quantum is not quantum, right? So you really have to have a detailed look. So if we not just look at quantum computing, but quantum in general, we have the columns of sensing, communication, and of computing, and they have different levels of maturity. Mm-hmm. They have also different challenges. If you go to quantum sensor, I mean, those devices partly, they have TL9, so they exist. You can buy them, and therefore us, it's a challenge then how you integrate this. So it's on us the challenge now to show that we can move on those technologies to a level that they can be used. And then maybe we find out in the end that it's not really, the performance improvement is not enough, or the commercial advantage is not there, and then we will drop some of those technologies. So not all of that, of course, will survive. But still, I would say that's a normal process. I wouldn't call that a hype, really. I mean, there's a certain exaggeration on some topics, but I think that's, in particular in sensing communication, we are maybe one step already advanced. In computing, I think it's a bit different. Still, I don't like the word hype too much, because I mean, what does it really mean? So I think we have, on the one hand side, really to acknowledge the immense progress in the quantum computing industry in the last years, which is really incredible. But still, I mean, we are all aware that there are many things still to be done. So there's just a very high risk, and I think the way how to address this is to also communicate those risks, and to also not to promise too much. In particular, in our roles, where we are kind of the ambassadors of this quantum technologies in the company. And I think if we do that, then maybe it's not a question if it's a hype or it's not. It's just we are making the best use out of this potential technology.
Yeah, it speaks to our responsibility to be very objective and to maintain that perspective for our particular companies. I mean, in a way that's independent of which part of quantum technology we're looking at. We can, right? It's no different if there's hype because some sensor has been developed and is out there and in the world today, or some capability that's created from that, than it is from the future capability of computing, right? It's about being objective about the reality of how that impacts us and what risks are remaining in getting that to the capability it needs to be, right?
Yeah, and I mean, in the end, I would assume, so I really cannot imagine that if we meet in 10 years from now, quantum will not play a role. I mean, it will somehow be implemented in the portfolio, but we will have a down selection, and we will, not all of the ideas we have today will work. So that's at least my best
I'm sure
guess.
you've down selected, I'm sure.
Yeah, sure, yeah.
Right?
If you back up 10 years, I don't think any of us would have thought the pure ecosystem would be so noisy. I mean, just to think of or even the tools that are available, and the things that are available, even with a click of so many different types of engineers that can get on platforms so easily and honestly partly for free. So 10 years from now, I think this panel will probably look quite a bit different as well, because aerospace may not know exactly what one of these things will look like.
Yeah, it's just, I don't know, setting realistic expectations as we spread the quantum gospel, this good news of quantum computing, but remembering to set good limits. And I think my leadership has a lot of really good expectations, and they understand the limits of the current hardware, and also that we might not see anything for like even 20 years, which I'm not saying that's what I think. I don't actually know what I think about when we're going to get good algorithms. But it is also, it's always really, it's kind of a learning and educational experience when someone sends you a headline like wormholes being realized, or desktop quantum computers that are at room temperature that we could have today. And I think they're always cool, promising results that sometimes might get misinterpreted, but they're also, there are times when we can like really be like, oh no, well let's learn from this. And also, I mean, when someone like randomly pings you one of these things, it's kind of like, oh, well, I don't know if we can do that today, but let's work together towards the future when we can. So,
right.
Yeah, I don't know.
Dani, I'm sorry. Thanks. Dani, just a moment ago, you made a mention of free tools that are now available, and I was curious to talk about the cost of systems, and certainly quantum computers right now, a lot of them can be pretty pricey, and I was wondering if you see the technology that you're working on. You're all working at very big, deeply resourced companies, and is this likely to be technology that's going to provide another sort of spacer or added advantage over startups, or is it something where you think that eventually there will be accessible, affordable tools like CAD that everybody will be able to use?
I mean, history tells us that there will be a day where those types of things, or if you even, there was the talk this morning that's talking about the price of a transistor today versus 50 years ago. The reality is I think there is an assumption that, large Fortune companies can realistically and responsibly pay for access across all these platforms. In my experience, that's not the case, and that's why we have to be very strategic about who we partner with. These are very expensive resources. That being said, I think if you look at the cost, it's not just about the dollar, it's not just about the check you have to write, it's about who is the right partner that you think you can impact their technology roadmap, because we are not at fault tolerance. So we have to understand, what are the other things, in a long-term way, as far as a classical competitor to a hybrid quantum classical system, there's things like power and infrastructure and things like that inherently will be built into the cost advantage of using a quantum resource versus using a purely classical resource. So the cost is a challenge. It's not a challenge. And I think even, to Jay's point about using other parts of our business, whether that's the ventures arm or other types of funding mechanisms, at least at Lockheed Martin, I am not opposed to finding any type of opportunity to find the right partner, because these are very expensive resources, and I also have to pay my people. So it's important to balance those things.
Yeah. I guess I'll go next. The the thing that came up in answering that question is that, I think that the best indicator to me that tools are going to be available and that the barrier to entry is going to be lower is, kind of looking backwards to the first time I came to Q2B in 2019. Almost all of the people on the exhibit floor were compute providers or software companies that sold the service of helping you figure out how to write a quantum algorithm. And today, if you look out there, there's a tremendous admixture of kinds of businesses. There are compute providers, there still are those consulting type businesses, but there also are tool providers. There are software companies that are not focused on algorithms themselves, but on tools to help the person who's actually going to be using these computers to become more effective. And the fact that there's this dramatic change in the composition and the price points really for initial access to compute have gone way down means that this is going to be a positive development over time. And I don't think that, I think that for the kinds of very large calculations that many of us are envisioning employing, yes, there's going to be some barrier to entry to be able to do those. It's going to cost some initial amount of resources that's probably beyond somebody walking up with a credit card and feeling comfortable just laying it on the table and buying the quantum computing time to solve that particular challenge for that particular run. But I don't think it's going to be out of range for companies of pretty much all sizes, from relatively small to big multinationals.
Yeah, so maybe I have a different opinion, or at least I would say when you think in terms of the time evolution about that. I mean, what will happen when we have the first fault-tolerant device? So the price is always what is requested and what is offered. I mean, we will have maybe one company providing this for the first time. So then there will be only maybe 1 or 2 machines available, so not many resources. So I think in the transition period, it's going to be very interesting. How is it decided which problems we are going to use? Are we going to apply? Which use case are we going to look to solve? And I think that's going to be very interesting.
Money's going to talk a lot there.
Money will talk a lot there, I guess. Maybe it's even governments who decide
Right.
about the problems. And I think maybe it's a bit more a philosophical question, but also from our responsibility overall, we should also decide, okay, what is the most urgent use case for mankind to be solved there? So I think that's a very interesting, it's going to be very interesting times. And let's say it's maybe best case 5 years, probably it's going to take a bit more, let's say 10 years. But then I think we will come to this point where there will be a period where these capabilities will grow, where we have probably kind of very strange situations, super high prices, a lot of governmental regulations. But then I agree on the long term. I mean, I guess if there's this capability there, and if there's the demand there, the industry will provide, the computing industry will provide the solutions. And I hope very much that companies like Airbus, like also the other companies, they will be able to use that, and I think also smaller companies.
Well, I would imagine we're all learning this right now. I mean, there is an extent of resource limitation across these emerging platforms already. So, from an aerospace perspective, we have the privilege of getting in the door because we have a very strong customer, or we have a very strong industry space that allows us to have these really hard problems to solve. But I mean, we're already seeing sort of the resource constraint of these emerging quantum computing companies. We're very large, they're very small. It's emerging, it's a challenging technology area. So I agree. I think, yes, that will be a thing, but I also believe we're already sort of living that, and we'll have some of those lessons learned along the way.
Yeah, it's like the priorities and the queuing on, I don't know about anyone else, but just like waiting for your jobs to run, like
Yeah, that's a very practical way to
or-
visualize it.
Yeah, I mean, it's like, and you can have these like live like run times and stuff, but those have their own give and takes, or there's like system rentals and things. Yeah, but I think this idea of almost like quantum market making of like who can actually who can offer like the funds and also the problems that are most necessary both for people and for mankind. So I think that'll be pretty cool. But I think ultimately, it could just go the way of like cloud computing with resources like AWS and Azure that where we have these like massive GPU machines, right? These GPU instances, and maybe in the future we'll have QPU ones soon that are, or maybe even just like hybrid ones, right? So I don't know. I think there's and like with those also there will be definitely like different sizes of quantum systems through to the future, the ones that maybe we're using for our really large CFD runs, and also ones that like smaller companies and smaller organizations can take advantage of.
So commercial aerospace is intensely regulated for safety, and certainly the FAA. There's a lot of concerns right now over how they're going to certify the safety of autonomous systems, AI systems, and quantum computing also would seem to pose a lot of questions as to how to validate the safety and of sensors and systems designed with QC processes. So, how much of an issue do you think it's going to be to sort of develop the means to validate and verify?
Why don't you start?
Yeah, I think it's like something we should probably get ahead of right now, and we can probably even try to collaborate over in the meantime as we're starting to see how these problems might arise in the future. And so yeah, we're even right now starting to think about these things and just kind of prepping for that period, and then also just going back and forth with what the administrations like actually need to see with these such that we can be prepared for the future. But I don't know. What other ideas do y'all have?
Yeah, so I think it's a very important point that you are mentioning, and it's something it's also I think a bit our responsibility to trigger this discussion now. So in my view, this is like not really a company specific problem. It's really that we have to come together to elaborate about the question, propose a solution, and then address the authorities in the end to prepare them, because they will need to take this final decision. So I think there's also already, I mean, these discussions are about to start. I mean, this is already, let's say, running. In my view, some very good forums for that in the moment are these, let's say, QDC, quick organizations, which are very important for us. Airbus is also there engaged, for example, in Europe and Quick. We are one of the founding members. Mm-hmm. And there are working groups who tackle exactly these kind of questions. And I think what we have to do is to come up with a good solution, and then to propose this in the end as a point of view of the industry, to make the authorities aware of that. I mean, this decision doesn't have to be taken right now. This is just they need to prepare already now for that. And I think it's a good point, because we need to start this now. So we cannot wait and, let's say, wait until the first small, say, photon quantum computer is there. So we have to prepare right now, and it's a good time to do that.
I look to the history of the aviation industry, which has predominantly been that industry has led regulation as opposed to regulation leading industry. For the most part, I mean, there are exceptions to that, but aviation has a 100+ year history of the members of the industry innovating, and not just innovating in ways that are consistent across the industry. There's going to be ragged implementation among the various companies within that, but And then having that discussion as an industry with the government organizations that are responsible for ensuring that the way we approach, the way we approach being safe in our products is consistent, right? If there's one thing that I think everybody on this stage would agree upon is that safety is not something that we should ever believe that we cut corners on, and so we will not. None of our companies would tolerate that behavior. In order to go through this idea of certifying the outputs of these computers, really what we're trying to do is make sure that we can have that discussion to convince them that we understand these well enough, we understand the calculations well enough to be able to ensure that we are both innovating to help better our products, but doing so in a way that maintains that level of understanding that leads to safe products. And that is something that I know, again, everybody on this stage will stand behind 100%. And so we're going to have to, as an industry, do this. We are, I think, among us starting to do and have these conversations. And this is something that we will probably push on individually and collectively over the next few years, so that those discussions happen with the government agencies, so that they're educated, so that they understand what our perspective is, have the opportunity to build up their people, to understand what they need to have, and then we can have a dialogue about arriving at that appropriate balance between what the regulator deems is needed and what we feel is warranted.
Yeah, and I completely agree. I think, we, at least generally across the quantum ecosystem, sometimes it's interesting to see where aerospace and defense is going to play, but this is absolutely something we know the best. We understand how to deploy these systems and make them safe and make them reliable for our customers. And so this should be the responsibility of us. And yeah, I'm confident that we all see value in that, and hopefully can start moving the needle on that in the next couple of years, because once we do have some sort of small scale capable piece of hardware that could even just do a small deployable problem, we have to be ready for that, or we won't be able to verifiably deploy that.
Put another way, none of us can basically take advantage of the potential value of a quantum computer until we solve the certification problem. Because we live in an industry that we have to certify the output of our computations if they are part of the design basis of our product. So it's very simple.
Yeah, I would also say it's really, so it's also not straightforward. I mean this is...
It's simple but really, not straightforward. That's exactly, that's the great way to put it.
Yeah, I mean in the end we have a new technology. It's also with AI, it's not straightforward. It's challenging.
It's a whole hard.
And that's why I think we need this time. And if we are not starting right now, then in the end we will not be able to benefit from it. So that's why it's really it's really to start now.
Yes.
Yeah, it's not the first barrier to being able to have value. It's the last one, but it's not the first one. We can't solve it last.
We can't solve it last. Yes.
Well said. We're almost out of time. Wanted to give folks in the audience a chance to ask questions.
Going back to the topic or the discussion about applications. Hi, I have a question about use cases and applications and algorithms. On that topic, in a heterogeneous computing environment in your shops, I'm curious about what your thoughts are about partitioning of applications, partitioning of algorithms across different types of computing platforms, general purpose computers, GPUs, FPGAs, neuromorphic nodes, and maybe quantum computing nodes. What the state of the art is and what your challenges are and what your needs are to be more thoughtful in terms of profiling the workloads of these applications to figure out which pieces might be the best fit with different types of computing nodes.
I can start. So I think I think all of our companies, we are operating HPCs, for example, in our industries, and I guess most of us, or I guess all of us, we will agree that hybrid approaches, they are like very likely to be implemented first. So that's why this is something we're actually looking into at this moment, how we can actually do that. But we are not yet that far that we can really say this is the perfect solution. But in the end, I think it's a very, very important topic. So it's already beyond, let's say, use case exploration. It's the way how I integrate a quantum computer in the end in my workflow and to my HPC systems. And you are right that, again, you have to start quite early, at least to think about the overall architecture. I think, in my view, in the end, there's going to happen a lot in the next years. Because, I mean, we are coming now to applications. We have now an understanding which applications, with which device we can solve. There's now the next step we can do and start thinking about the workflow integration.
And if you look at, I mean, if you, in listening to all of our presentations, our workflows are relative, I mean, the kinds of things that are going to be in the workflows within our companies are relatively similar. So you're likely to see kind of a tendency towards a particular architecture within us. It may be a little bit of a spread there, but generally speaking, we're going to optimize the architecture around the kinds of computations we use. And what we're going to use is going to be very different than, say, what a finance company is going to use, or what a healthcare company is going to use, or what, I mean, pick your other favorite industry that's trying to go work use cases. We have particular classes of problems, and they're very similar across everybody in the industry. And so you're going to see our hybrid solutions are going to tend towards a certain kind that probably is going to favor problems of large scale, problems that, you know, things where we can try to address the huge, voracious appetite that our companies have for doing basically linear algebra, you know, basically PDE solvers. You know, you cannot provide enough capacity for PDE solving. We've tried. You provide enough, and we figure out how to do more, how to use it more and more effectively earlier in our process to do more what ifs, and so we end up oversubscribing the new capacity, and we just, it's a never-ending appetite for those kinds of things. So again, our architecture is going to look very different based on the needs and uses and kinds of computations that we as an industry are going to face. But yeah, it is all about understanding how that architecture is going to come together and how to understand how to make good decisions about how to partition that workflow amongst those elements within the architecture.
Yeah, I mean, agree again. I think it comes back to several questions we've answered, which is it's a very complex problem that has lots of different resource needs. And the reality is classically, we have a lot of experience in even choosing across the different opportunities you mentioned classically. So we can take some lessons learned on, you know, when does quantum make sense as a part of that architecture. But the reality is for a number of years longer, the quantum computational resources within that architecture are going to be the most expensive. And so how do we balance, you know, fiscally how we're leveraging those resources? And again, it comes back to the use case where there will be things where quantum or a quantum classical solution is the only solution. And then at that point, we don't really have to ask or answer the partition question because quantum has to be there. So it's a very, there's many layers to how we're going to ultimately define that, but I think it will look very similar, but also depend on the type of use case you're doing, whether it's machine learning or optimization or things like that.
In 10 years, 15 years, 20 years, pick your time scale, do you feel like the quantum processor will be in your facility sitting next to an HPC, or do you think you'll be using it over the cloud?
I think that's going to depend more on communication technology than almost anything else. I think, although the second caveat to that is there are problems I'm sure each of our companies has where we only do our compute on premises, even though we might have the opportunity to do solutions in the cloud. And those kinds of customers and those kinds of programs are never going to go away. So I think you're going to see both. I don't think it's a matter of one or the other. Just like We don't do all of our HPC is not in-house. Most of it is in-house, but we also have, we also go work with cloud compute providers to use cloud computing resources for those high-performance calculations. It's not, I think, if you'd asked the question and we were focused on quantum computing 20 years ago, 30 years ago, would have been a very different answer. At that point in time, it would have likely been, hey, yes, there's going to be a need to stand up in-house resources and everything's going to be, you know, managed, corporate managed. But I don't think that that's the environment of the future. I think the environment of the future is a mix. There will be places and instances where we will likely have to procure things at great expense, but those things that we're doing that for with great expense come with requirements to do that that will justify the cost. And likewise, there will be times when we're able to use cloud-based solutions, and those will work just fine, and we will be perfectly happy to continue doing that.
Yeah, I think this is, so I fully agree. And one thing to add, I think this is very specific about aerospace. So we will, for sure, at some point, we will need on-premise capabilities for certain problems. And I cannot imagine that the regulations will change in the way that you really do everything cloud-based. So I think that's something which makes our life then harder or more interesting, because that's something we need to prepare for. So this is, I mean, because it's not just the device you will buy, there will be a lot of challenges in the first generations, how you really operate this. Also, what of the knowledge you need then on site to basically make this operational. So I think it's going to be very, very, very interesting, but still it's also taking some time, right? So it's not something which will start tomorrow.